This is a course project from BME 595 Deep Learning. Our project title is Citation Purpose and Polarity Classification with Convolution Neural Network and Recurrent Neural Network. According to different studies, the number of scientific works is doubled every 5 to 10 years. In academia, finding the relevant information for research is important. However, with this large amount of published papers each year, it is hard for us to make sure the papers we find are the most related to our research or whether we miss some other important papers. In this project, we make use of the citation sentences in the paper and use it to predict the polarity and purpose of the citation. We then use the training model to label the citation polarity and purpose in different papers. Our ultimate goal is to build a concrete citation network with abundant information such that researchers can find useful or relevant paper when looking at a graph. This project is inspired by the following works. From Woodrick and his colleagues, we found that citation network has been implemented as a tool to assist researchers for finding relevant research. One of the work they have done in the paper is to use machine learning algorithm to classify the polarity of the cited paper. Since it was published in 2010, when deep learning at the time was not as prominent as it is today, the algorithm they used for automatic classification may not be optimal and need heavy works on feature engineering. This inspires us to apply deep learning techniques for automatic classification. In deep learning, this kind of classification problem is a classic sentiment analysis problem, where RNN has shown its value. However, during the literature review, we found blogs and papers using CNN and also have good results. In this project, we implemented both RNN and CNN models and compare the results. Our data is mainly from the first and the second paper. We have 10,000 citation contexts annotated with citation polarity and citation purpose. Note that some of the citation contexts were not labeled with citation purpose. Therefore, we have about 2,000 for purpose and the other 10,000 for polarity. In the polarity, we have 3 categories: positive, negative, and neutral. As for purpose, we have 6 categories, which are comparison, criticizing, basis, substantiating, use, and neutral. So please note that from the table, we can see that the distribution is highly skewed to neutral class for both classifications. So our first step is to clean the data. We found several concatenating sentences which pollute the dataset. So we manually added spaces to those sentences and make the sentence more reasonable. Our next step is to use GLOVE, an unsupervised learning algorithm for obtaining vector representations for words developed by Stanford, to map the vocabulary to vectors. The purpose of using word embeddings is that these have been shown to boost the performance in NLP tasks, such as syntactic parsing and sentiment analysis. Then we feed the input sentences into RNN and CNN models. Since RNN has shown its success in NLP area, our first step toward the project is to build LSTM and GRU model to predict the citation purpose and polarity of the citation sentence. From the literature review, we also found that simple CNN with hyperparameter tuning can achieve the excellent performance in NLP tasks. Unlike in image case, where the inputs are the width times the height times the number of channels, we use the mapping vectors from previous stage as an input. We set a max length of each sentence and add 0 padding to the sentence which has length less than the max, so that we fix the length of the input sentences. The first layer convolutes the vectors and result in a feature map. Then it applies max pooling to get the most significant features. Then we get a fully connected layer with dropouts and softmax output, which is our classification. Finally, we got the prediction for polarity and purpose. So on the left-hand side is the input sentence. Then on the right-hand side, we can tell the polarity is negative and the purpose is criticizing. The GLOVE word embedding has been trained from 2 different corpus. One is from Stanford pre-trained with Wikipedia data, which we considered as generic corpus. The other is trained by using SEO anthology network corpus, which considered as domain-specific. So here is our result. From the result, we can see that the domain-specific love is about equal to generic love, which is greater than an embedding from PyTorch. And the second one is that the CNN with atom optimization is greater than LSTM and GRU with SGD. Then finally, we found that the balanced school data has the best performance among the polarity. This is our report. Thank you.